Hello everyone. Now we're going to solve some problems involving these trigonometric functions that we just went over. So the first thing I'm going to find is the sine of the angle Q. The angle Q is the one over here. And how does the formula sine go? Well, sine is just the opposite, which I'm going to abbreviate OPP, over the hypotenuse, HYP. Well, what side is opposite to Q? Opposite meaning directly across from the angle. Well, that is this side. It's not 6, it's actually B. So B isn't exactly what we want. We have to find out what number this side is actually equal to. Well, we have a right triangle and we have two sides. So if we have two sides of a right triangle, we can definitely find out that third side. How? We just use the Pythagorean theorem. So we have 3 squared plus b squared equals 7 squared. 3 squared gives you 9 plus b squared equals 7 squared, 49. Subtract by 9 on both sides to get b squared is equal to 40. And therefore b is equal to the square root of 40, which is also equal to, and we're gotten to the point where we hopefully can simplify radicals. Well, 4 is the same thing as 4 times 10. And if I split that up further, that's the square root of 4 times the square root of 10, which equals to the square root of 10. The square root of 10 is definitely not going to break down any further because it's just 5 and 2. So this right here is what b is equal to. 2 times the square root of 10, which is our opposite side. So we have our opposite is 2 times the square root of 10. Over the hypotenuse, what a hypotenuse is the longest side or side, and it's also opposite to the right angle. So that has to be 7. So that is the sine of Q, 2 square root of 10 over 7. The next trigonometric ratio I'm going to find is the cosine of R. A different angle, so we have to kind of approach it in a different way. Well, what is R? R is the adjacent side over the hypotenuse. So what is the adjacent side of R? R being this angle right here. Adjacent means right next to, but it's not the hypotenuse. Well, the only side you have left over is actually B. B is going to be our adjacent side, so on the top we put 2 square root of 10. And maybe you see where this is going, but we then put the hypotenuse, which is 7, in the denominator. So we have that the cosine of R is 2 times the square root of 10 over 7. And what's interesting about this is this tells us that the cosine of R is equal to the sine of Q. And we'll work a little bit more with that idea later. But for now, let's move on to our last trigonometric ratio, which is going to be the tangent. And we're going to find tangent of Q. And what's tangent? Tangent is opposite over adjacent. Well, what's the opposite side of Q? Well, we know that's 2 times the square root of 10 over the adjacent side being 3. So that's 3. So that's it. Those are the 3 I want to find for now. Now, one last thing we're going to take a look at. What do I get? And this will be important a little bit later. But what do I get when I do the following? I'm going to take the sine of R and square it. I'm going to add that with the cosine of R squared a. Well, what will this be equal to? The sine of r is, we're going to look at this side r again. And again, sine is opposite over the hypotenuse. The opposite side is 3. The hypotenuse is 7. So we have 3 over 7 squared plus the cosine of r, which we already know is 2 square root of 10 over 7, and all that's squared. So what are these two things equal to? Well, let's start with 3 over 7 squared. This is real simple. You just take the top, the numerator, squared at, so it's 3 squared, that's 9. The bottom, 49, because it's 7 squared. And we do the same thing on the other side. So 2 square root of 10 squared is going to be equal to 4 times, well, the square root of 10 squared is 10, which is 40. So we have 40 over 7 squared, which is 49. Add them together, you get 49 over 49, which is equal to 1. So maybe this might be some sort of important formula. I don't know. It might come into play later, but that's just something interesting we just found out just by doing some simple math.